check this picture out. Here's our question. Given an equilateral triangle on top of a square that's also then on top of an isosceles trapezoid with the given side length. So this is given that this distance here is 14. The height, I guess, of the trapezoid down here is 8. And the distance, the base down here is 23. That's all we know. The question is to find the area of everything. Well, here we go. What I've shown you is, you can pause this actually, I'm going to tell you this. You can pause this right now and try to figure out on your own if you want to. I'd recommend probably doing it. So I'll wait a second so you can pause it. That's my freeze frame face. Do you like it? Okay, let's go on. So hopefully you did it. Hope you did it. That's beneficial if you do, but let's show you. So my thought is this. I got 3 shapes. Equilateral triangle, square, trapezoid. To this point, I know how to find the area of all 3 of those shapes. So why don't I break it up, divide it and conquer it into the area of a triangle. I'll add that to the area of the square. I'll add that to the area of the trapezoid, and I will get my final answer. And I will be happy. So, which one's easiest? Probably, well, I don't know. It really depends on how you look at it. But I see all 3 of these numbers given to me for the area of a trapezoid. So why don't I just plug it in for that? So if you focus down here, I have the area of a trapezoid. It's 1/2 height times the sum of the 2 bases. So since the height is 8, I'll take that 8 and I'll plug it in right here for h. And I know the 2 bases are 14 and 23. So I'll take those 2 bases and plug them in here for the sum, or the b1 and b2. Add that all up, and actually here's what I get. I get 4, because if I take 1/2, if I take 1/2 times 8, it gives me 4. And I take this times 37. So there you go. Hopefully you can see that work. So and I multiply that out. That would give me 148 units squared. So that is the area, if you will, of the trapezoid. 148 units squared. So that's this. 148 units squared. Sweet. Okay. So we got that thing. The next one, actually, you could have seen this might have been easier too, but the key thing is knowing, wow, I don't have anything up here, I don't know anything. Well, I guess I do know this. It is an equilateral triangle. That's kind of important. So anyways, let's keep on going. I'm going to work my way up the figure because I know this thing right here has a length of 14. Uh-oh. How am I going to figure this out? Well, wait a minute. I know it's a square. Well, that's pretty simple. So that means this has to be 14. So the area of a square is just s squared. 14 squared is 196 units squared. So hello, we are 2/3 of the way there. Or as I say in class, 2/3. Ew. That's not a whole lot of turds, but sorry, that's gross. Keep going. So now we got to find the area of the triangle. That's the toughest part. Easy for you guys, of course, but it's the trickiest part, I should say. You know that's an equilateral triangle. Here's what I know also. Since it's equilateral, I know that this is 60. I know this is 60. I know this is 60. I know we just talked about this. That has to be 14. Why? Because it's a square, so that has to be 14. So how do I find the area of that particular triangle? Well, I know it's base times height divided by 2. That's a triangle. So all I have to do is find the base and the height. Wait a minute. I know the base. It's already 14. So all I have to do now is find the height. Well, let's draw it. If I draw this bad boy right down there, which we've seen this a bunch throughout many questions in previous chapters, if I take that bad boy and divide that thing, well, sorry, if I draw the altitude, what it does, it creates 2 triangles that are actually 30, 60, 90 triangles. Which means this side, as we've seen before, is equal to that side. So I break up the 14 into 2 equal parts, which means this has to be 7. Why is that important, Mr. Motter? Because of this. My 30, 60, 90 triangle across my 30 is what x is. Across some 60 is what x root 3 is. So since I have x is 7, that means this has to be 7 root 3. And that's the height of the triangle. So over here you can see that's why I put 7 root 3. So 14 times 7 root 3 divided by 2 would give you 49 root 3 units squared. So that is the area of the triangle. Sweet. So that means this is 49 root 3 units squared. So now my final answer. Oh boy. Some things are in jail, some things aren't in jail. Here we go. I can take the 49 root 3, 196 and 148, and I have to add all them together to give me the overall area of the entire thing. Well, that right there has a radical, root 3. That does not, that does not. So these things are all together not like terms. Just like, whoops, these are like terms, but all three are not. Here's why, as an example. Back to algebra, if I had 3x plus 4, you would never add those because they're not like terms. So that's why you wouldn't add 49 root 3 and 196. It's a similar concept. They're not like radical parts, so they're not like terms. But I can take, if I had like this, 5. I could take the 4 and the 5 and add them together because they're just numbers, so that would give me 3x plus 9. So I'm going to do the same thing. I take 49 root 3 and the 196 and 148. I can put these together because they're like terms, which then finally gives me an answer, weird answer, 344 plus 49 root 3 units squared. And that is my final answer. I cannot take 344 and add it to 49 again because they are not like radical terms. So there you go. Go back and watch these things because I know that was lengthy and in detail, but it's awesome. Good stuff. Look forward to seeing you.